Hello everyone, this is Math 1332 video lesson chapter 1 section 2. This section deals with graphs, estimation, and models. Let's begin by looking at what these mean. An estimation is a process of arriving at an approximate answer to a problem or question. The optimal word is approximate. For example, if you were asked to multiply 23 times 48, that would take a lot of time because you have to do 48 times 23 and then do all the math there. Approximate estimation uses approximation. So what we do is we'll take the first number, round it down, up or down to the closest whole number that we could deal with. So 23 is closer to 20, and 48 is closer to 50. So 5 times 2 is 10, and we have 2 extra zeros behind there. So our answer is approximately. That's what those squiggly lines. Whenever you see those squiggly lines, that means it's an approximation. It's approximately 1,000. Okay, let's see what this read would be. 8 times 3 is 24. 3 times 4 is 12. Plus 2 is 14. 8 times 2 is 16. Carry the 1. 2 times 4 is 8. And 9. So 4, 6 plus 4 is 10. 10, 11. Yeah, it's pretty close. But it's a ballpark. It's an approximation. So, like when we're shopping, it's $1,000. Do we want to spend that much? Yes or no? So, that's all this is about. That's all estimation is about. Rounding. Rounding is taking a number to an agreeable, we'll call size. Determined by the individual. Or so if you're rounding, that's what we did here. In this case, we rounded down in that one and up in there. The rules for rounding is first, choose which digit or decimal you want to round to. It all depends, because here, this is the ones, this is the tens. I wanted to round up to the tens. And if you have decimals, you have certain names for them: tenths, hundredths, thousandths. If it ends in a TH, that's a decimal. talk about that in a second. So choose a digit or decimal you want to round to. Then look at the digit one space to its right. If that digit is between 0 and 4, just drop that digit and every digit after. If it's a decimal. If a whole number then replace those digits with zeros. That's if it's between 0 and 5. If that digit, remember we're talking about the one to the right of the one we're looking at, is between 5 and 9. Then round up the chosen digit to the next integer. We're using a lot of words there. Digits, whole numbers, integers. Let's look at this. What we mean by these things. First off, we have natural numbers. Those are our counting numbers. If I ask you to start counting, you always start at 1, 2, 3, 4, 5, and go on to infinity. Or whenever you want to stop. But if we add a 0 to the list, we get whole numbers. I remember that. So when there's whole numbers, start with 0, which is a whole, and all the counting numbers. So on and so forth. Dot, dot, dot. And each of these numbers here are called digits. From 0 to 9 are digits. From fingers in our hand. All right, so let's look at the rounding rules. We're going to look at 1, 4, 5, 7, 2, 9, 3, 6. It's 4,507,000. And then we're going to look at a very small number. 24.9. 1,2,3,5,9,7,6. If we have just integers, numbers, no decimals, these all have locations. This is the ones. The next one is the tens. Then the hundreds. Then we're getting the thousands. There's the 1,000s. Then we have the 10,000s. Then we have the hundreds. 100,000s. Then we have the millions. There's the 1 millions. Then there's 10 millions, 100 millions. Then the billions, 100 billions, or 10 billions, 100 billions. So it keeps on going in that pattern. It goes ones, tens, hundreds, 1,000s, 10,000s, 100,000s, 1 million, 10 million, 100 million. But when we have a decimals, it goes backwards. The first number back behind the decimal is the 10th location. Then it's the hundredths location. Then the thousandths. You notice how each one of these ends in 10,000s, tenths, and then keep on going. So it's thousands, 10,000s, 100,000s, millionths. So now let's look at rounding. I want to round to the, let's see, the 10,000s, or the 5th location. So we have 4, 5, 7, 2, 9, 3, 6. So the 10,000s are the 5th. 1, 2, 3, 4. Oops. That's not supposed to be back there. So the 5th location, ones, tens, hundreds, thousands, 10,000s, is the 5th number, 5th location. So what I do when I'm rounding, I look at the number to the right. Since that's between 0 and 4, I just make all those numbers, since I'm rounding to this one, since these are all less than 4, I just make them all go 0. So I rounded this one, so I don't change it whatsoever, and make everything behind it zeros. Let's go to the thousandths here. Round to the thousandths. Or the 3rd decimal place. 24, 2, 3, 5, 9, 7, 6. Notice now in the decimals we don't put commas. It's only for the big numbers. Here's the tenths, hundredths, thousandths. We're rounding to that number. So we look to the right. Since that number is between 5 and 9, I add 1 to the one I'm rounding. So it becomes, instead of 5, it becomes a 6. And everything behind it goes to 0. And there you have it. I rounded to the 3rd decimal place, which is the thousandths. Since the 4th number was 9, I added 1 to it. and Mariel 0. Since I was looking for the 5th location, I go to the 4th location. Since that number is between 0 and 4, I round down. So all those become 0. So I went down here, I went up in this one. That's rounding. And the last thing we're going to discuss, we're going to look at in this section, are graphs. We have 3 types of graphs. Circle graphs, or as commonly known, pie charts. What pie charts do, it shows a whole object divided into smaller sectors. And those sectors are represented by percents. And it shows us how much of that entire picture that sector takes or represents. So if you did one for your budget, you have the whole circle there. You have, let's say, 45% goes to rent, 15% goes to entertainment, 30% goes to food, and then 10% savings. All of these all percents must equal 100%. That's the first one. Then we have a bar chart. Bar chart is a way of comparing some measurable attribute or aspect of various items. Okay, in bar charts and in next one in line graphs, the x-axis, if you ever deal with time, x-axis, the bottom axis, always deals with time. And the vertical, the y-axis, deals with money, number of people, or whatever you're examining. And line graphs look at trends over time. And that's what we're going to look at today in our examples. All right, so our first sheet. In the past year, companies spent $593,749,545 on advertising. Round the advertising figure to the nearest 100,000. It's ones, tens, hundreds, thousands, 10, 100,000. So we're rounding it to that number. So 593,749,545. Since we're trying to round to that one, we look at the one right before it. If it's between 0 and 4, make all zeros. Everything behind it zeros. If it's between 5 and 9, add 1 to the number rounding to, and the rest zeros. So, since that's between 0 and 4, we make all of these 0. So we're rounding down. This one rounds down, this one rounds up. So our answer here is C. In the town in California, the average consumption of soft drinks per day per elementary school student is 14.739 ounces. Round this value to the nearest tenth. 14.739. Yeah, in decimals, there is no oneths. The first one you begin with, that's the tenths. Then hundredths, then thousandths. So we're going to round to that one. So we look at the next one. Remember, if it's 0, between 0 and 4, just drop them, make them all zeros. Since that's 3, we just drop them. If it was 5 or higher, then we would add 1 to that one, make it an 8. So 14.700, everything to the right of a decimal is nothing. So the answer is D. Solve the problem with estimation. Do not use a calculator. Use rounding to make the resulting calculation simple. Estimate the cost of 988 shirts at $19.95 each. Okay, so we have 2 digits. That's a 9. That's an 8. So we can it's closer to 100. So we'll round it up to 100. 1995. The closest dollar amount there is 20. So 20 times 100 is 2,000. So the answer is C. Solve the problem with estimation. Number 4. Do not use a calculator. Use calculator. Use rounding to make the result calculation simple. Find the estimate of this. We have 0.229 times 80 0.533. So we can't, nothing around that one. So we can round this one. We want it to 1 decimal place. So that's a 2. So we just have a 0.2. And this one is 0.5. Two goes into 5. Well, since that's not going to help us, we can round up. Reason being because 0.3 goes to 0.6 twice. Because this one here, we could do it, but it would be 2.5. Again, now that one's going to be very difficult because 3 doesn't go into 80. But 2 goes into 80, we have 40. The answer is 40. So estimation, I mean, you could jiggle it up, down, whatever you need to, as long as it follows a rule. The bar graph below represents the various colors cars sold. What colors sold over 50,000 cars? Okay, here's the cars. Here's how many they sold. Which color sold more than 50,000? Red. Number 6. The bar graph below represents colors of cars sold. Which color sold under 20,000 cars? Here's 20,000. So this one is yellow. The one for sure is yellow. D. Number 7. The bar graph below represents various colors of cars sold. Estimate how many more black cars were sold than silver cars. Okay, so that's just over, so let's say it's 41. 20. So 41 minus 20. 21,000. Since the units are in thousands, it's 21,000. So 7 is D. Because I mean there is no 20,000, so we have to look at that one closer. The line graph below represents the price of stocks over a course of a day. At what time is the stock price the lowest? Well, it's lowest. This is the stock prices. The lowest it is here. It's at 9 o'clock in the morning. So it's C. Round to the nearest 100,000ths. So it's tens, hundreds, thousands, 10,000ths, 100,000ths. So we look at these numbers. We look at the number there. Since that's the next number, we're rounding to this number. Since the 9 is between 5 and 9, get rid of those, and we add 1 to that one. So it's 29261 4. 0.2614. Round to the nearest 9 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm rounding to that one. So I look at the one below it. Since that's a 1, get rid of those. So my answer is 2.5412880033. 8033 is A. And the last one, match the story to the correct graph. The hazardous liquid oozed more and more slowly. More and more means it's gradual. Let's look at these pictures. This one's, that's not slowly, it's getting faster. Okay, it's decreasing, it's slowing down. This one's increasing. And this one, so it has to be B, because it's slowly slowing down. Alright, those are those. Good luck, and we'll get to the next one.